Hello students, from this session we are going to begin a new chapter. We are done with physical world and units and measurements. You can solve many problems from units and measurements. You can find them in the NCERT given. Even you can find so many online sources regarding which will give you the questions for competitive exams also. So from this session I am going to begin with motion. In physics, we study a lot about motion, and motion is of various kind. Okay, if I leave an object, it falls down. That is motion. A car moving involves various kind of motions. You might think, no, sir, it is only one motion which is happening. Car on the road. If you observe carefully, the car is moving in a straight line on the road. That's right. But the wheels of the car are undergoing rotational motion, and the piston of the engine is undergoing oscillatory motion. Like that, even though certain motions look simple, it involves various complex motions in them also. So in physics, we are going to understand all those kinds of different kind of motions. So before we understand any complex uh, subject, we always look for the basic of that. Before we read a novel, we should begin with the alphabets of English, isn't it? That's how everything begins. Even in the understanding of motion, in order to understand all different kinds of motion, right from a falling object to the motion of planets, to the motion of a car, to the motion of a bob of the pendulum, to the motion of a spring, etc., etc., we should first understand the simplest possible motion. You might say, sir, yes, we do understand the simple motion. In the first place, which is the simplest possible motion? Simplest possible motion is the motion of a body in a straight line. If the body is moving in a straight line, it will have certain characteristics to it, characteristics for that motion. And if we understand those characteristics, we can say, then we understand the motion. Now the question that comes is, which are those characteristics which we need to understand so that we can have the idea about entire motion. And before I go for those characteristics and discuss about them, I would like to give you the basic idea that any motion or any phenomena in physics can only be said completely understood if we connect that phenomena to math. So without mathematics, physics is always incomplete. But many a times, yes, we have to assume and begin the concepts, but by the end, we have to make use of mathematics to prove our assumptions. So, as similar to any other phenomena in physics, even the motion can be taken or can be said as completely understood only if we can prove whatever we understand mathematically. So, in this session, we'll be taking the simplest possible motion, which is the motion in a straight line, and we will understand the characteristic of that motion, characteristics of this motion, and also we'll take the mathematics in that motion, so that we have complete idea about motion in a straight line. And after doing so, yes, we will move ahead for motion in a plane, motion in 3 dimension, rotational motion, oscillatory motion. All kinds of motion can be understood in the coming chapters. So, as I say, the motion that I am taking now will be restricted to a straight line, and the chapter itself is named as motion in a straight line. So, uh, let me take an example and begin it, or let me give you an idea what is the motion in a straight line by comparing the motion in, in a plane and in space. You can assume that if you have a straight railway track on which you have a train moving, that can be considered as motion of the train in a straight line, or in other words we say that as motion in one dimension. When we have the motion happening in a plane, somewhat like an ant moving, if I leave an ant on the board, that can move in the on the plane in two dimension. What is two dimension and one dimension? Dimension is very simple. It is the number of axes that involve in the given uh, coordinate system. So if I have a single axis, like for a train, because it's a single axis, either it should go forward or should come backward. That's it. It cannot take left, it cannot go right. No, that's not possible. For such a motion, the motion is restricted to one axis. You can call that axis as x, y or z, but it's always only one axis. We will have the option to choose the axis name. We generally name it as x-axis, generally. But there is no rule that we have to name the axis as x itself. We can name it as y, we can name it as z. Now, that's a single axis, and hence we call that as one dimensional motion. But when I take board, the board has two dimension. If I leave an ant here, it can go like this, come back like this. So the ant can move on the board in along x-axis and together also along y-axis. So this kind of motion is called two-dimensional motion. Now, which is also called motion in a plane. Moving ahead, what is motion in a space or motion in three dimension? I hope you got the idea by now. If you imagine, or if you just think of a bird flying in certain region, the bird flying uh, in a region will have, I mean, three-dimensional freedom, or I can say the bird can move horizontally along x-axis like this. The bird can also move vertically along y-axis or z-axis that we call. The bird can also move like this. So, the bird has three-dimensional freedom to move. So, that kind of motion of the bird in three dimension is considered to be motion in space or motion in or three-dimensional motion. So, in order to understand motion in two-dimensional or 2D we call, and motion in 3D, we should first understand motion in 1D, and we will apply the same mathematical interpretations to both motion in 1D and motion in 2D and 3D further. So first, we should understand motion in a straight line, which is also called motion in one dimension or motion in 1D. So as I said, I'll take the same example of railway track on which a body is moving, you can say normally train is the body which moves on the railway track, right? But now this time I am going to take a person who walks on the railway track. So this railway track is extended to large large distance on both sides. Okay, it is going like this, and it is also going to large distance like this, and it is a straight track. Now you are the observer, one who is standing here, and except this railway track and a tree here, you do not have anything else in the surrounding, or anyway anything in the uh, given region. So now what happens is, a person initially comes, a person is observed. You are someone who is standing at certain distance and watching what is happening here. Then what happens is, a person comes and stand at this point. Okay, while walking, he rests at certain point like this. Then you are asked, where is the person standing? Then you respond, the person is standing behind the tree, or you can say it's not even behind, few meters away from the tree, to the left of the tree, isn't it? Few meters, because you do not have any measurements here. You can approximate somewhat, like the person may be standing 20 meters to the left of the tree. That is how you respond. And in the next state, or in the next situation, a person might be sitting on the railway track, and if you are asked, where is the person now? You will respond by saying, the person might be 22 to 25 meters to the right of the tree, right? That is how you respond. So what comes to the mind is, whenever we locate certain object, we always make use of a reference. And in this example, tree is the reference, and we are locating the position of the person. Now comes the tricky part. One fine day, some or few people come and cut the tree. And now there is no clue that where was the tree. And there is nothing else except railway track. And now, if you are asked to locate or say where is the person standing, then you'll feel confused. Forget about this person, these two are the same person. Okay, this is the first case where he is standing. This is the second time when the same person sits on the track. Now you are asked, where is the person standing? Then you will have no idea how to respond. So without a reference, you'll think over it, right? Okay, how to locate now? He is on the railway track. That everybody knows. He is on the railway track. He always goes on the railway track, because our motion is restricted to one dimension. So he can't go away from the railway track. You assume that this railway track is on the bridge, and hence he cannot go on away. It's completely water everywhere. So then you start to think how to locate this person. We cannot locate the position of the person without any reference. So that reference chosen for locating the position of the object itself, because this time I can say, go and put go and plant again, okay, or reinsert tree in the place, or you building at this position so that you can locate. But that's not the permanent solution. So the permanent solution for setting up a reference is choosing a coordinate system in the given line. So what is that coordinate system? Coordinate system is simply set of numbers where 0 is taken at certain point. Okay, it's not mandatory that 0 must be at the center. No, it can be anywhere, and to the right of the 0, to the right of the chosen 0, okay, we will number with different units as with positive integers like this: 0 plus 1 plus 2 plus 3, 4, 5, 6, 7, 8, so on. Similarly, to the left of the 0, we need the readings, and we will name them using negative integers: minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. So this coordinate system, or this coordinate, because it's only one coordinate that we have chosen, is always important to get the reference chosen, to get the reference required to locate the position of the object. So now, if see this coordinate system, what I have taken can be uh, both real and imaginary, which means you can take a paint and put the numbers on the track. That's also possible. But even if the tracks do not have any real numbering, sometimes ourselves need to imagine those numbers on the track or on the line in general and assume the position. So now, if you are asked, where is the person standing? Now you can easily say, very easily say, the person is standing at minus 4 units. Yeah, we have not yet decided the units, but it's fine. Minus 4 units. Unit can be meter, centimeter, kilometer, anything. We can decide it later. So the person is standing at minus 4. Where is the person sitting? The person is sitting at plus 5, isn't it? Now we can easily locate the position of any object using the coordinate system, or coordinate, because only one coordinate is chosen. So using the coordinate that we have chosen. So this itself is considered to be the x-axis. This itself is considered to be the x-axis, and this axis will have 0 and 1 positive numbers to the right of the 0, and negative numbers to the left of the 0. Now, if certain object is moving in this straight line, then how do we say in the first place whether the object is moving or not? So, in order to be clear with that, in order to be clear with that, whether the body is moving or not, we must have one more factor in the given arrangement, which is time. So, how do we, you can say, If the body is moving, it is moving. If the body is not moving, it is not moving. That's how we can say, right? That's very simple. You think, no, it is not. Because you assume a car, the driver of the car, according to the driver of the car, the person sitting next to him is in rest, isn't it? They are not moving with each other. The driver, according to the driver, the person sitting next to him is in rest. But the same person is in motion for someone who is standing outside and watching the motion of the car, isn't it? So, you can't say the motion is absolute, which means it is same for all. No, we say motion is relative. Okay, this is an important point, keep this in mind. Motion of an object is always relative, it is not absolute. Okay, very basic point. Motion is always relative but not absolute. And you might say, sir, what if I'm standing simply like this? I'm in rest for all of you, everybody who is observing me. No, it is not, because yes, if you are standing still on the ground, absolutely you are in rest for all the person who are on the earth. But for an observer who is on another planet, we are actually undergoing rotational motion and revolutionary motion because earth is moving, isn't it? So motion can never be absolute, it is always relative. According to whom am I moving? According to whom am I in rest? That is how. So now the question is according to. When the question of according to comes, someone might be observing from rest, the observer might be in motion, himself might be in motion. So the best possible observer that we choose is the coordinate system. So according to the coordinate system, okay, according to this coordinate system, if we are in rest or if we are moving, then we can describe the motion. So whatever we discuss is always according to the coordinate that we have chosen. So now, time is the other factor which comes into play now. So if, so 4, -4 is the position of the object now for this example. If the position of the body does not change with time, which means a person comes and stands at this point and stands still at that point for a long time. So according to the coordinate, okay, according to the coordinate, the person is not changing his position, right? So very simple, then we call the body or the person, the body, we generally name it as body, okay, we call it as body. Then we say the body is in rest. And if the position of the object changes, if the position of the object changes with respect to time, then we say the body is moving. Okay, clear with this? So it's always time which will decide whether the body is moving or in rest. If the body changes its position with respect to time, then we say the body is moving. If it doesn't, then we say the body is in rest. Okay, very important point, take that. If a body changes its position with respect to time, we say the body is in motion. If the body does not change its position with respect to time, we say the body is in rest. Okay, so that is about the basics of motion, very basic points of motion. Now, okay, we do not have anything much to discuss about a body in rest, right? A body in rest is always in rest, no problem. Let it be in rest. Whatever the time that we measure, that we take, the body always the body is always in the same position. So we do not have any complex math, anything else to discuss about a body which is only in rest always. So we will avoid discussing much about rest now, and we will come to the body which is moving, or the body which is changing its position with respect to time. Okay, and we will understand the motion from now onwards. Now, say the body is at this position when we started observing the motion. Okay, so we are the one who are observing the motion, and our frame of reference is set with the coordinates chosen. We and coordinates are not moving, we are fixed. So we find that, see, this body might be undergoing various kind of motion or different kind of any kind of motion before we start observing it. This might be going like this, undergoing any motion before we observe it. But uh, the motion is always considered after we start observing the body. Okay, so keep this in mind. We will not worry about what is the, see, if I say a car is moving, when I saw the car, it was moving. That is the reality. If I say the car was moving when I started the observation, that's fine. But if I say the car is initially the car was moving, then that is wrong, because initially car was always in the rest in the home, and it just begin its motion from the home and came to this position. But we started observing the car from this position. Before this position, we did not know what was the status of the car, how was the car going, what happened with the car. We are not bothered about it. So the motion is always considered from when we start to observe the motion. Okay, we do not bother about what happened before the observation, and we will also not bother about what will happen to the motion after the observation ends. Say we have a window and a car enters the view and exits the view. We can only study the view or the car's uh, range that we have to see, and beyond this and this, no, we cannot understand the motion, and so we will not bother about it. We will only worry about this part of the motion. Okay, be clear with that. So now a body is at certain position -4, say at certain time. Okay, we will not take the factor of time now. Okay, at certain time, and it takes little time and starts to move this from this point, and it goes to say position 3, and it stops there for a while, and from 3 it again starts to move and goes to point, say uh, position 8, and from 8, don't know what happens. See, I have told you, even though it is motion in straight line, the body will have the freedom to move forward and backward. Okay, so from the point 8, it starts again to move, but in the opposite direction, and comes back to 5. So this is the complete motion of the body. Starts from -4, goes to 3, then to 8, and back to 5. And now the body is at 5. Now, if you are asked about what is the, or if you are asked to describe this motion, then you would say Okay, the body started its motion from -4 and then went to 3 and stopped a while, and then from 3 to 5 it went, and again from 5 to 8, and it went from 3 to 8 and returned back from 8 to 5. But this is not the way in which we represent it in physics. We always make use of math and certain characteristics that we define, certain factors that we define. We will make use of them and express the or describe the motion. In order to describe this simple motion that we have here, we will take two factors. One factor is path length. Very simple, because whenever the motion happens, we always expect to know what is the length the body has moved, isn't it? If I throw this sack and if it moves in a straight line, then I always expect the body, the sack, the basic factor that I should know is the length traveled by the body, isn't it? So that is one important characteristic that we will understand to describe the motion. So what is path length now? Path length is the total length of the body or total length traveled by the body. Okay, very easy. So let me take for the same situation, what is the total length traveled by the body? Before that, I will name the points, positions as A, second position as B, third position as C, and final position as D. Now for this particular motion, if I ask what is the total length traveled by the body or length of the path traveled by the body, okay, that itself is path length, which is also called distance. Okay. So if I ask what is distance or what is path traveled by the body, then it is the very simple, the length of the path, traveled by the body. Now, what is path length or what is distance traveled for this example? Now, it starts from A is -4, right? -4 to 8. What is the distance traveled? If you find it difficult, I can give you the idea of measuring it by counting the length. So 1 unit, 2 unit, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So from A to C, it has traveled 12 units. Okay. And now, how do I get that? Either you can count, or the other way to get the path length, okay, other way to get the path length, see the path is AC now, right, is subtract final position, subtract initial position, okay, from final position. So it is final position, P is the symbol used for position, final position, P subscript F, see, P F, small is the subscript, okay. Should not write it as P F, no, these are the wrong ways. You should always write it like this, subscript it is. So final position minus initial position will give you the length of this particular motion, okay, not the complete motion, be clear with that. So, before that I should go for, because the body has rested at point B, no, so I should consider the length from A to B first. So the length traveled by the body in the complete motion is A to B, B to C, C to D again. So when I take from A to B, okay, AB is equal to, see, finally it is 3, minus of minus 4. Okay, final position minus initial position, or even you can count, it will become 3 minus into minus plus 4 is equal to 7. So, if I start counting from this position, it is going to be 1, 2, 3, 4, 5, 6, 7. Yes, it is right. Now, from B to C, which I can call as BC. So, from B to C, the motion, the length the body has travelled is 8 minus 3, which is 5 units. See, 1, 2, 3, 4, 5, right. Now, it comes back from C to D, which is, what is the final position? Final position is, here comes the tricky part because it is moving in the opposite direction, and it's always the magnitude of the motion that we consider. 1, 2, 3. Okay, 1, 2, 3, 3 units. Don't take it as final position minus initial position, then you will take the negative sign. Okay, if you take that as negative, it will be, it's actually according to the rule, it will become final position is 5, initial position is 8, so it is minus 3. But when I take path travelled, we will not consider any negative signs. We always add up, because see, you can assume it as such. Say the body is moving like this. What you are going to do is, you will take a tape and start measuring the length of the path. Like wherever the body goes, you will take the tape and keep on measuring, keep on measuring, keep on measuring, comes back and again you will keep on measuring. That is how you are finding path length. Okay. So, what is the total path length of the motion? Total path length of the motion is AB plus BC plus CD. Okay. So, we will not worry about the negative sign, it is always 3, because we are finding the distance travelled, the or path length. So, AB is 7 plus 5 plus 3. Got the idea? It is the length of the path. Whatever the path it goes, we have to go in that path and measure the length. Okay. So, totally the length of the path travelled or path length or distance for this motion is going to be 7 plus 5, 12 plus 3, 15. 15 units. Okay. Clear? So, this is what is path length or distance travelled. Quite easy. Length of the path travelled by the body itself is distance or path length. Now, this is the quantity which we know, and every quantity will have its own unit. The SI unit of path length or distance is meter. Right? We all know this, represented by small m. Okay, and the dimension of path length or distance is L. Okay, or L1 or simply L is also fine. Okay, so this is about distance. Now, which means we have to just measure wherever the body goes. We need to keep measuring the length, and hence we will finally get the path length. Clear? There is one more term which is very similar to this, and we will take that now. And now, there is one more factor which helps us in describing the motion. But this factor will not give the complete detail of the motion. Even then, it is going to be very important for us to discuss and understand that factor. And the new factor that we will take is called displacement. What is displacement? See, the body always starts from certain position, motion always starts from certain position and ends at certain other position. If we are not bothered about the complete motion, instead if we are bothered only about the initial position and the final position, then we say, what is the shift that has happened, isn't it? Say I start the motion from this point, go like this and go like this, like this, like this, and come back to this position. So for a person starts for a so certain observer, a person observes the motion in the beginning where the body was here, and then it goes like this, like this, like this, and comes back to this position and stands. The person observing will not observe any kind of motion that is happening. Instead, he only gets to know the initial position and the final position. He don't know where and all has he went. Just like you people go from school to home, isn't it? What parents know is you leave school and you reach home like this. But it is not like that, right? You always take a path like this, like this, like this, like this, go to friend's home and some chat center, and from there to some other place, and then you reach the home, right? So, parents, the observer, the person will not know the complete motion. So, for such observer, another factor is important, which is the shortest possible distance. Okay, shortest possible distance between final position and initial position of the entire motion. Okay, for the entire motion, the initial position and the final position are important for the person, and we'll only take the shortest distance. Okay, so now what is displacement? Displacement is the shortest distance, or you can put this as shortest length, that's also fine. Okay, shortest length between final position and initial position. Okay, this is the definition of displacement, very important. Now you tell me, what is the displacement for this motion? Displacement for this motion is, you always look for the final position. What is the final position? Final position of the body is D, and initial position. What is the initial position? Initial position of the body is A, and the shortest distance between them, okay, the shortest between the bodies, shortest distance or shortest length between the positions, to be precise, final position and initial position, okay, itself is displacement, which means I should now measure it from A to D. That's it, directly. That is the displacement. Okay, how much the body has shifted. We will not bother about where and all it has went and come back. We will only look for how much the body has shifted, the shortest distance or shortest length between initial and final position. Shortest length is this itself, this much, right? Longest length can be anything, it can be infinity, no problem. But now it starts from this point, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 units is the displacement for the same motion. Okay, 17 units, not 17, sorry, 15 units is the distance for this example, but 9 units is the displacement for the same example. Okay, clear? Understood? Okay, now how do we get that 9 units mathematically? So, mathematically we treat displacement as a vector. Okay, now comes, I'll take this part in the next class, vector and scalar. Just keep this in mind, distance is a scalar, displacement is a vector. Okay, scalar quantity is a quantity which has only magnitude. Vector quantity is a quantity which has both magnitude and direction. So, which means if I say uh, what is the path length, then I say 10 meters. And then the next question cannot be answered if it is a scalar. What is that next question? In which direction is the path length 10 meters? No, you cannot answer that because the body started its motion from this point and it went like this, like this, like this. There might be complex motion involved and it might be changing its direction anytime. So, and it's only the length of the path that we are concerned, right? So, the second question, in which direction the path length is 10 meters cannot be answered for the motion, okay? Because this motion does not have unique direction. You cannot say the body has moved uh, 15 meters to the right, to the left. No, it has, yes, it has moved to the right, then it has changed to the left again. So, distance is a scalar quantity. Okay, distance is a scalar quantity which has only magnitude. Magnitude means number. 15 meters, yes, that's fine. But in which direction is it 15 meters? No, you cannot answer that. And similarly, this one, displacement, is a vector quantity. What is a vector quantity now? Vector quantity is something which has both magnitude and direction. So now, for this example, if I say what is the displacement, I can easily say the displacement is final position minus initial position. Finally, it is 5. Initially, it is minus of minus 4. Okay, final minus initial, which is equal to 9 units. So, the displacement of the body is plus 9 meters. Okay. Keep this in mind, displacement can be both positive and negative, but distance is always positive. Distance can never be negative because it is always the magnitude that we are bothered and it has no direction, and here the negative sign has a significance. What is that? Negative sign gives us the idea that the motion is happening in the opposite direction of the coordinate. Okay, so see, this is the actual direction of the coordinate. From 0, positives goes here. So that is how the direction is. It's always like this. Okay. Now, since the body has moved from A to D in the positive direction, we obtained plus 9 meter as the displacement. Okay. Now, for the complete motion, the displacement can be taken as plus 9 meter displacement. But if I take one more example, say just this part, I will not worry about all the different motions that has happened. I will only assume that the body started its motion from C, ended its motion at D, that's it. Okay, clear? I will only take this much. So, for this example, when the body starts its motion at C and ends at D, the initial position is 8, final position is 5, and hence the formula gives us final position minus initial position is equal to minus 3. See, displacement now for this motion from C to D is minus 3 meter. Okay, that part is done, don't worry about it. The complete part is done with this. For A, B, C, D, it is done there. But now I have considered one more example, one more motion, where the body starts at C, ends at D. No other motion is considered. Okay. For this motion, displacement is minus 3 meter. What do you mean by this minus 3 meter? Minus 3, the negative sign associated with the number shows that the body is moving. Our body has shifted to the opposite side of the coordinate system. Okay, because coordinate system has direction like this, but the body has shifted opposite to that. Okay, somewhat like it has moved to the left. If it has moved to the right, which is the direction of coordinate system, then positive number. Okay, since it has moved to the left, the displacement is taken as negative, which is minus 3 meter. Clear with this? Why minus 3? Because the body has moved to the left or in the opposite direction of the given coordinate system. Okay, so displacement can be both positive and negative, and hence the negative displacement shows the motion of the body in the opposite direction of the coordinate system. So yes, that's it about displacement. Yeah, displacement also has the same unit, meter, and same dimension, length. And we represent displacement using, in some references they put x, in some references they put s. Okay, both x and s are used to represent displacement. Clear with this? Okay, so and for the same motion from C to D, if you are asked what is the distance traveled, distance traveled is always positive. So from C to D, the distance traveled is plus 3 meter or simply 3 meter. It's always 3 meter. Whether the body goes from D to C or from C to D, it's always only 3 meter. Distance is always 3 meter. But for when we take the displacement, if the body goes from D to C, it is plus 3 meter. If the body goes from C to D, then it is minus 3 meter. Clear? So that is about distance, displacement and basics of motion. And we'll take it further in the next session. Thank you.